P1 stands for price, P2 stands for the next price level, that is the change in price. Price and quantity as that is being followed, and we are going to understand how the quantity supplied, quantity is taken on the x-axis, price is taken on the y-axis. So you will be able to see the sloping line towards left. This is your demand curve, this is your supply curve. Good morning and welcome to the first revision session in Unit 1, second semester BDT, Business Decision Theory, where we are going to talk about some of the graphs and problems that are involved in supply and demand. So this session is all about the graphical representation of supply and demand and some of the problems that are concerned in that chapter. So let's go further and try to understand the graphical representation of supply and demand. Although it is normal to regard the quantity demanded and quantity supplied as the functions of price of good. Now this is very important. Why? Because the price of good is always determined with quantity supplied and quantity demanded, and the standard graphical representation is usually attributed to Alfred Marshall because he has the price on the vertical axis, quantity on the horizontal axis, the opposite standard of convention for representation as the mathematical function. So we are going to now represent price and quantity as that is being followed, and we are going to understand how the quantity supplied and that of the price demanded for the good is going to be calculated. Now if you start looking here, since the determinants of the supply and demand are on the other side, that is about the question that comes in picture here is not explicitly represented, the value changes and the variables are moving in the supply demand curve, which often we call as the shift factor. Please have a look into the graph. It will be easier for you to understand. Now, when there is going to be a shrink or when there is going to be an downward time in terms of demand, you will see a demand push curve coming to inward side. That means this is the first demand curve, D1. Now the demand has reduced. That means we will draw a graph, a line here D2, which is on the inward part of it. When the supply increases, that means there is a shift. The shift is towards the right hand side. So from S1 it has moved to S2. Now in the case of demand, it's a shrink. That means it is moving inwards, that is leftward side from D1 to D2. That is what we are representing graphically. Before we start this, we need to understand this factor very clearly. We are taking the price on the vertical axis. Now we are taking the price on the y-axis, quantity on the x-axis. Now here P1 stands for price, P2 stands for the next price level, that is the change in price. P1, P2. Now what happens here is that when the price falls down, then automatically you can see the shift demand that's happening. Similarly, there's a shift on the supply part. This is what we want to explain in terms of the graphical factor. By contrast, response to changes in the price of good are represented as movements along the unchanged supply and the demand curve. So we are representing here in a graphical manner the change in the price movements, followed by when an organization begins determining the price of a given product or service, the objective is to optimize the profit through maximizing revenues and minimizing cost. A very important factor that we have to understand in demand is that we want to optimize the profit. How? By maximizing the revenue. Revenue should increase, cost should come down. So that is what we are looking into. To do so, projections of demand and fulfilling that projected demand with appropriate supply to maintain optimal price point is the central strategic endeavor of the market. And that is very, very important for all of us to understand. Why? Let's try to understand here very clearly. When we are talking about the projections factor, one thing that is coming into our mind is that we have to fulfill the projected demand. Whatever is the market demand, you need to fulfill it with the appropriate supply. Suppose there is not appropriate supply available in the market, then you will not be able to serve the customers at any given point. So it is mandatory that you maintain both demand and supply, and then you reach an optimal price. That means the supply and demand curve will meet at an optimum point, which will be decided as the price of the product, and then we take it as a strategic endeavor for the marketer. Forecasting demand and understanding the elasticity of demand for various types of goods is greatly empowered by systems built to manage yield. So that is what is the most important factor here. That's what we need to understand in terms of the growth, in terms of the factors, how the demand starts moving up. Now the next thing here is that let's look at the estimation of demand factor. If you look here, as the price falls down, the demand will increase. That's the law of demand. So when the price falls down, the demand will increase. If the price increases, the demand will fall down. That has been clearly shown here. So you would see that the quantity expansions are given by Q1, Q2, P2 and P1 are the prices. Quantity is taken on the x-axis. Price is taken on the y-axis, so you will be able to see the shift in the demand curve, and this is the supply curve that's moving in. So you will see 2 points, 2 equilibrium points where the price of the product will be decided. Now I would call that as the optimum price altogether, because that's where the supply and demand are meeting each other. Now the next thing is that to tell you exactly how we do it, let's take one demand curve and one supply curve. The sloping line towards left, this is your demand curve, this is your supply curve. Now this is the price factor and this is the quantity that has been mentioned. Again, price on the y-axis, quantity on the x-axis. Now what we are trying to do is that we are going to find the equilibrium point. This is the equilibrium point where the price of the product will be determined. So always remember, the point at which supply and demand meets, that point would be considered as the equilibrium price, the optimum price for the product. Now, moving further, we all know that demand curve is a sloping curve which is moving towards from the top, from the left to the right. So this is how it will be. From the left to the right, it is a sloping curve, and this is what we call it as the demand curve. So now when you see two products, the price of A, price of B, quantity of A, quantity of B. So what you see here is that if the price of A is greater than that of B, then product B will be selling more. The demand will start going more because product price of B is lesser. So you see here, product A is costlier than product B, and that's why the quantity demanded will be less. The price of product B is lesser, so that's why the quantity demanded for product B will be more. This is how we will be estimating the demand factor altogether. Moving further, we are now trying to solve some very, very simple questions in demand. No need to worry, this does not include much of mathematical analysis. It's a very, very simple problem. All you just have to substitute the value, you will be able to get the answer. Now here is the question. If the demand supply curve for the computers, it's given by the equation D is equal to 100 minus 6P, that's the demand, and the supply is S is equal to 28 plus 3P, where P is the price of the computers. What is the quantity of computers bought and sold at equilibrium? How are we going to do it? We are going to equate these two equations. So let's try equating the equation. 100 minus 6P is equal to 28 plus 3p. So we have written down the equation here. You will be able to see we are going to equate the equations here. If we rearrange the equation, bring this side, all the numbers to one side, 100 minus 28 is equal to 6p plus 3p. So 72 is equal to 9p. So p value is equal to 72 divided by 9. So 72 divided by 9, the answer is 8. This is how you need to solve this problem. It's a very, very simple problem. Two equations would be given. You have to just equate both the equations. You have to bring all the numbers to one side, variables to other side, then divide it. You will be able to get the answer. It's a very, very simple problem. Now, the question number 2. On the one, we also know that the equilibrium price, we can solve the quantity similarly. So what we try to do here is that you put that value 8 in the equation of supply. The supply equation was S is equal to 28 plus 3p. So here we know the value of p. The value of p is 8. So let's start solving here. 28 plus 3 into 8. So which is 28 plus 3 into 8 is 24. So the answer is 52. So when the equilibrium price is 8 rupees, the quantity is 52. So that is what we have been able to achieve here. So when the price is equal to 8 rupees, because we were able to find here p value is 8 rupees. So when you substitute this in the equation, try to solve it, you will be able to get the quantity value as 52. This is a very, very simple problem to be solved. Now, the next one. The quantity demanded for good Z depends upon the price Z of PZ and the monthly income Y, price of the related good PW, which is given. Now the demand is given here, the function is given, QZ is equal to 150 minus 8PZ plus 2Y minus 15PW. For all the values have been given, price has been given here, Y is the income factor, PW is the related good. Find the demand equation for the good Z in the term of price Z, where Y is equal to $50, income is $50, related good is $6. So we have all the information in the problem. Let's try solving it. So the equation is written here, 150 minus 8PZ plus 2Y minus 15PW. So what you have to do, you have to now fit in the values here. So you know what is the value, 150 minus 8PZ. Y value was given as 50, that is income is 50. 2 into 50 minus 15. PW value was $6. So 15 into 6 that you have to substitute. So you will get 150 minus 8PZ plus 2 into 50 will be 100 minus 90. So when you solve this equation, you will get 150 minus 8PZ plus 10, which will make the equation 160 minus 8PZ. This is the final answer that we have to get. It's a very, very simple one. You just have to substitute the value in the equation. You will be able to get the entire step of actions that have been told here. Moving forward to the third question. A firm charges $800 for its unique word processor. If the total revenue is $56,000 in July, how many word processors were sold for that month? It is very, very simple. Quantity is equal to, how do you find the value here? Let's first understand the total revenue. Total revenue formula is price into quantity. Now, we know the total revenue. So you have to use the formula of finding for quantity. So automatically, if you have to find for quantity, it will become total revenue divided by price. Now, what is the quantity? How we are going to find it? Total revenue is already given, that is 56,000 divided by the price factor is given there, that is 800. So 56,000 divided by 800 will give you the final answer as 70. So this is the amount that we have found out. This is the quantity. Quantity is equal to 70 for the month of July. So the company has sold 70 word processors for the month of July. That's how you have to solve this problem. It is very simple. All you have to substitute the value. Total revenue is equal to price into quantity. Here we have to find the quantity. So the formula changes to total revenue divided by price. Total revenue is already given, that is 56,000 divided by the price is also given, that is 800. 56,000 divided by 800 is equal to 70. That's how you will find the value here. Followed by the fourth question. Find the slope of an assumed linear demand curve for theater tickets when purchased 1,000 at $5 per ticket and 200 at $15 per ticket. Now, this is what we have to find out. So, change in price by change in quantity. That's the answer that we are going to look into. The most important formula here is change in price divided by change in quantity. So, how are you going to do it? The first thing, when $15 to 5. So, 15 minus 5 divided by 200 minus 1,000. So what is going to happen? 15 minus 5 is 10. But at the bottom, please look at the denominator. 200 minus 10 is negative value. So that will be minus 800. So the value will be minus 1 by 80. So this is the change that has been given. So the slope of the ticket curves is given by minus 1 by 80. So all you have to do, change in the price divided by the change in the factors. 15 minus 5 divided by 200 minus 1,000. So you will be able to get the answer here. Now, the next thing, fifth question, where we are going to calculate, we have been given widgets. Widgets is given, the demand function is given, 80 minus Q. Supply function is also given, 20 plus 2Q. So all you have to do is again equate the equation all together. So let's equate it. 80 minus Q is equal to 20 plus 2Q. So let's just put the equation here. So when you take the equation, 80 minus 20 is equal to 2Q plus Q. So 80 minus 20 will be 60. 2Q plus Q will be 3Q. Now find out the value of Q, that is 60 divided by 3, which is equal to 20. So the quantity value is 20. That's what you need to find out here. It's a very simple thing. Equate the demand function and supply function. You will be able to get the value of Q. Now, the next thing is that our equilibrium quantity is 20. So you have to substitute in the equation. Let's take the first one. The demand function P is equal to 80 minus Q. We know the value of Q, that is 20. So 80 minus 20, the answer is 60. So for our equilibrium quantity is 20 and our equilibrium price is 60. That's how you need to solve this particular problem. Moving further, question number 6, again the same kind of thing. The only thing here is that we might change the number. Why? Because now the suppliers are getting full price. So here a tax factor of $6 is being added. So what is going to happen is that the same 80 minus Q will now become equal to 26 plus 2Q. Why is that 6 is being added? Because there is a tax factor that has been added. So if you see here, 80 minus Q is equal to 26 plus 2Q. So you are adding it up. That will become 54 is equal to 3Q. Q value is 18. This is how you are going to find out. It's the same kind of equation. The only thing is that when you have been told that there are certain factors like tax coming in, so the tax will be automatically added to the supply equation. The rest thing is the same, from where you will be able to find the value of Q. Now, our equilibrium function where we are trying to find out, we know the value of Q. The Q value is 18 here. So again, solve it in the same equation. P is equal to 80 minus Q, where 80 value, 80 minus 18, P value, you will get it as 62. So when the equilibrium quantity is 18, the equilibrium price with tax, that is more important, is 62. And the equilibrium price without tax will be 56. Why? You will be subtracting it from value that is 62. When you subtract 6, you will be getting the value without tax, that is $56. This is how you need to solve the problems in demand and supply analysis. With this, I come to the end of the session. I hope and believe that all the information that is being shared through this particular presentation will be of great benefit and help to you. In the upcoming sessions of revision, we shall talk more about the terms and terminologies in demand and supply. Until then, stay tuned, stay blessed, and stay enlightened. Thank you once again for joining me today on this wonderful session.